Complements for probabilities. So remember that a complement for a set, or in this case, an event A, is written A with the superscript C. And sometimes we'll see it A apostrophe or A prime. So the complement of an event A consists of all the outcomes that are not A. And this is very similar to the complement of a set. You're looking at things that aren't in the set. So let's consider rolling a 12-sided die. And A is going to be event of rolling a 1, 2, 9, or 11. And I just kind of made up these numbers to illustrate a point. So A is going to be the event of rolling a 1, 2, 9, or 11. Then A complement would be everything else. It would be what's missing, 3, 4, 5, 6, 7, 8, 10, or 12. And if I had a Venn diagram to showcase this, A would be a subset of the universal set U, or you could think of it as S, either way. And inside A would be 1, 2, 9, or 11. So I could write those there. And outside of A complement would be 3, 4, 6, 7, 8, 10, and 12. With this Venn diagram, I could showcase it as a cardinality Venn diagram and just write how many elements are in each region. So inside of A, I have 4 elements. And then outside of A, I have 8 elements. And this is really useful in determining probabilities. So let's see that in action now. We've got our cardinality Venn diagram. I moved things up for a little bit of space. And now I can ask some questions here. So let's figure out, what is the probability of A? What's the probability of rolling a 1, 2, 9, or 11? So that's going to be the number of elements in A divided by the total, 4 over 12. There were 4 things in A, and I want to divide that by the total number of things in my sample space, which was 12. And I can reduce that to 1/3. And then similarly, I have A complement. And I can look at my Venn diagram and say, okay, well, in A complement, there are 8 elements, and I want to divide that by 12. So again, I can reduce to 2/3. And something again to notice here is, if I take the probability of A, 1/3, and I add it to the probability of A complement, which is 2/3, that gives me 1. So that's the idea of a complement. It's always the missing pieces that come together to create the whole. So 1/3 plus 2/3 equals 1. And that's not a coincidence. So this is what we just said. Probability of A plus probability of A complement is equal to 1. And this always happens. It's not just special for this example. This is a mathematical certainty with complements. So what you can do here is, let's say we knew the probability of A. Well, then I could find the probability of A complement by just subtracting 1 minus probability of A complement. So this second equation is had just from subtracting probability of A from each side. So let's see it in action. If we have the probability of A equal to 0.0182, then we can find the probability of A complement. We use our formula, 1 minus the probability of A complement. So let's see. We'll put this in our calculator, 1 minus 0.0182, and we should get 0.9818 for the probability of A complement. So it's a very straightforward one-step equation. And that's the answer to this question. So now you're done. Isn't that nice? Sometimes we're going to have fractions, but I'm still going to use the same formula. So 1 minus 12 over 17 in this case. And I want us to remember that any number over itself equals 1. So instead of 1, I'm going to use 17 over 17. And what this accomplishes for us is it gives us a common denominator. So I can go ahead and say that this is just 17 minus 12 in my numerator, and then I'll divide that by 17. So I get 5 over 17 as my final answer for the complement.